Hello, my name is Chris, and I would like to start by saying I apologize for any background noise or anything, but this is the best I could do. Thank you. I will be starting the presentation for Group 3 over traffic volume. Our 4 objectives were to make a literature report based on the topic. Number 2 is to analyze the data that we were given and to build a prediction model based on it. And 3 is to allow users to input data into that prediction model to find the traffic volume at that time or input. And lastly is to build an interface where users can input data and update the existing model and data that was given. So this is a very similar overview, but it's basically stating that each person has a junction and will do the objectives for it, and then base the best model, or the model they find most accurate, against the times of 2 a.m., 6 a.m., 3 p.m., and 7 p.m. And then obviously the visualizations and plots to better understand it instead of having to manually go through the data. And lastly, the interface to input and update data. I am junction 1. So I did .describe and .info to try and better understand the data or see if there's any anomalies. Not any that I think it found. And then visualizations, I did daily hours versus vehicle count. So, and then on the next slide, we'll have days of the week versus the average of vehicles that went through the junction, and then heat map for correlation. So these are those. The most notable one is the years versus the vehicles, in my opinion. That seems to be the most notable. And then models, we have the univariate, multivariate, and polynomial models. This is the univariate. It only goes based off hours to find the vehicle count. Yeah, I decided to just include the whole code, so it's just easier. The multivariate and the polynomial regression. These both take in month, date, and time to spit out a prediction. And then I decided to use both of those models to hand analyze which one would be more accurate. So from what I found, based on 2 random dates and doing it by hand, is that, and then these are the spit out, or the proof of the spit out, which is included here. Sorry that I call it spit out, the output, the result that is here. And so I found by hand that polynomial usually got closer to the mean or average of the 4 data points from the data sheet. And then so since polynomials seem to be the best, I decided to use it for the specific times. I used the polynomial model put in the specific times, and this was the output. 6 a.m. does seem to be an anomaly, or different than the expected, because the expected should be lower than 2 a.m. and it is not. So that does not seem very accurate based on the daily hours, our average daily hours graph that was shown first. It should be realistically lower because it was more around 30 and not 40. So that seems to be an anomaly, but that's the only comment that I've seen that doesn't, or that's the only thing output that I've seen that didn't really make sense. If like that makes sense. Yeah, thank you.
Hi, my name is Vivian Smith, and I am doing Junction 2 for the traffic analyze volume. So for my section of the project, I focused on Junction 2 and analyzed the traffic volume patterns using the traffic data set. Since the dataset contained over 43,000 rows of information, I first used the statistical tools of info and describe to better understand the data structure and the overall traffic behavior. This overall helped identify the important information, such as the average traffic volume, the peak traffic hours, and just how it would spread throughout the data. By doing this initial analysis, it became a lot easier to understand how the traffic changed throughout the day, at the different times, and prepare for the visualization and the regression modeling later in this project. After completing the statistical analysis, I created several visualizations to better understand the traffic behavior at Junction 2. This first graph shows the average hourly traffic volume throughout the day. This helped identify the busiest and the slowest traffic periods. And then the second visualization on my left, um, it mainly focused on weekly traffic patterns, which allowed us to compare average traffic volume across all of the different days throughout the week. And then on my right, finally, we have the correlation heat map of my Junction 2, which really helped show relationships between variables such as hours, dates, months, and the vehicle count. Overall, these visualizations made the traffic trends much easier to interpret and really help support the regression models later in this project. So, to predict traffic volume for Junction 2, three main regression models were developed and compared. The first model was the univariate linear regression model, which was only used for the hour variable to predict traffic volume. The model was simple, easy to understand. However, it did have limitations because traffic behavior depends on so much more than just time. And then the second model was the multivariate linear regression model, which basically means that this model included multiple variables such as month, date, and hour, which significantly improved accuracy and produced more realistic traffic estimates. And then our final model was the polynomial regression. Unlike the linear models, polynomial regression was a lot easier to follow the nonlinear traffic patterns more effectively. Since traffic volume changes significantly throughout the day and it's uneven, this model was ultimately the most accurate for Junction 2. Now, to evaluate the performance of the regression models, we needed to do multiple prediction tests to see their performance using the input values across all three models. For example, using one of the test cases, the univariate model predicted 16 vehicles, multivariate predicted 15 vehicles, and the polynomial model predicted 14. Although the predictions were fairly similar during the lower volume traffic periods, the polynomial regression model consistently produced smoother and more realistic predictions overall. This analysis showed that traffic patterns at Junction 2 are not perfectly linear at all, which explains why the polynomial model performed at its best when predicting the traffic conditions. And then for the specific times, for my final part of this project, the polynomial regression model was used to analyze the traffic volume at very specific times throughout the day. The selected times included 2 a.m., 6 a.m., 3 p.m., and 7 p.m. in order to compare both low and very high traffic periods. These predictions help demonstrate how traffic volume changes depending on the certain time of day. While larger traffic volumes appear during daytime and evening periods, using those specific times allowed us to better visualize real world traffic behavior and showed honestly how machine learning models can be used to estimate traffic conditions a lot more effectively.
Hello, Miliani Ressa, and this is the Junction 3 presentation for this project. It includes the analysis, the visualizations, and the models. So for the analysis, we had over 14,500 entries. So we had to utilize the describe. It was essential to see the levels of the overview and the traffic behavior. So that's what this is showing. And then for the visualizations, we had two different plots. We have the average hourly traffic, which is shown here, And then in the next one, we had the correlation heat map. Oops. Yes. And then, oh, no. Sorry. And then for the models, we had two as well. We have the multivariate linear regression and the polynomial regression. Those are being shown here. This one is the multi-linear regression, and then this is the polynomial. And then for the analysis, we had to compare them, which was necessary, so that we have like the accuracy of traffic prediction and behaviors. So that's what's being shown in these two boxes I see. And then based off of these, it basically proves that the polynomial is the more reliable one because it can work with any curves or new data. And then for the timestamps, or specific times I should say, we have the 4 different times, the 2 a.m., 6 a.m., 3 p.m., and 7 p.m. and it basically shows the different trends and behaviors of traffic at these times. And then for all the junctions, it's basically analyzing the traffic junctions, the different behaviors and predictions. And junction 2 showed the moderate traffic variations using statistical analysis, visualization techniques, and machine learning. These all helped improve understanding traffic flow and prediction accuracy. And then for the showcase, we have basically all of the junction model predictions I see from the 3 separate junctions. And then the update interface, basically it'll show you the month, day, and hour, and then the different predictions and behaviors. And then you can add or update them through here if necessary with new data and different behaviors. It started by using the polynomial model for accuracy, and then it will add or update anything automatically based off of the input given.